You think you know what a city looks like. Steel and glass, streets and sidewalks, light. Now imagine a city carved into solid rock, 1 kilometer beneath the surface. No windows, no sunlight. The weight of 1,000 meters of granite pressing down on every square inch of the ceiling. And a government that says this is the future. Not a shelter, not a bunker, a permanent underground city for 50,000 people. This is not science fiction. This is Saudi Arabia's NEOM project, and they are building it right now. But before you picture a luxury mall buried in the desert, you need to understand what happens to the human body when you live a kilometer underground. The answer is not comfortable. The answer might be lethal. And the engineers who designed this city had to solve problems that have never been solved before. The official story is clean. The line is simple. Saudi Arabia wants to diversify its economy. Oil is finite, so they build a new city, a linear strip of hyper-modern infrastructure called the Line, and alongside it, a deep underground complex for manufacturing, logistics, and even residential zones. The pitch is that the rock itself becomes the shield. From heat, from sandstorms, from the chaos of surface life. It sounds clever. It sounds inevitable. But that is the surface story. And like every surface story about deep engineering, it is incomplete. There is a reason no underground city of this scale has ever been built. There is a reason the deepest mines on Earth are some of the deadliest workplaces in human history. And there is a reason the people who actually build tunnels do not volunteer to live in them. The first crack in this story appears at roughly 200 meters. That is the depth where most conventional tunnel boring stops. Below that, the rock itself becomes unpredictable. Not solid, not stable. It shifts, it creaks, it sweats. Water seeps through microscopic fractures, and at 200 meters, the pressure is already 20 atmospheres. That is the weight of a column of water, 20 times taller than the Burj Khalifa, pushing against every seal, every gasket, every weld. Here is what nobody tells you about building at 1 kilometer. At that depth, the rock temperature is not related to the surface at all. It is geothermal. It is the heat of the Earth's core radiating upward through the crust. In the Mponeng gold mine in South Africa, the deepest mine on the planet, the rock temperature reaches 60 degrees Celsius at 4 kilometers down. 1 kilometer is shallower, but still. The rock will be at least 45 degrees Celsius. That is not a room temperature. That is a pot of simmering water. Now imagine tens of thousands of humans living in that heat. Their bodies generate heat too. Every person is a small radiator. Multiply by 50,000. The ambient temperature inside the city would climb toward 50 degrees Celsius in days without active cooling. And active cooling at that depth is not like running an air conditioner. You have to pump heat upward, against gravity, through kilometers of ventilation shafts. Each shaft costs millions to drill and consumes more energy than a small power plant. Stop. Think about that number. 50,000 people generating heat a kilometer underground. The geothermal gradient alone adds 1 degree Celsius for every 30 meters of depth. That means the rock surrounding the city is already 15 degrees hotter than the surface. And you cannot vent that heat sideways. The rock conducts heat at a rate of about 2 watts per meter per Kelvin. That is slower than a brick wall. The city would become an oven. But the heat is not the biggest problem. The biggest problem is the thing everyone forgets. The thing that collapses tunnels faster than any earthquake. Water. At 1 kilometer below the water table, the hydrostatic pressure is staggering. Every crack in the rock is a potential disaster. Every seal is a ticking clock. The ITA collapse report from 2022 documents a tunnel in Norway that flooded because of a 2-millimeter gap in the gasket. 2 millimeters. At 1 kilometer, that gap would have been a geyser. Saudi Arabia is building this city in the Arabian Shield, a region of ancient crystalline rock. It is stable geologically, yes, but it is not dry. The aquifer at that depth holds water that has been trapped for millions of years. That water is hot. It is mineral-rich. It is corrosive. And when a drill bit punctures that aquifer, the water does not trickle. It bursts. The only way to manage it is to pump it out faster than it flows in. At 1 kilometer, that flow rate can reach thousands of liters per minute. And when the pumps fail, the water rises. If what you are hearing started to shift something, stay. This is where that continues. The hidden truth is this: the underground city is not a single structure. It is a network of caverns, each carved by tunnel-boring machines weighing thousands of tons. The largest of these machines, the ones used in the Gotthard Base Tunnel, can bore 15 meters per day through solid granite. At that rate, carving a single cavern big enough for a neighborhood takes years. The city is planned to have multiple districts. That means decades of continuous excavation. And during that excavation, the rock is unstable. The stress redistribution around each new cavern triggers micro-seismic events, small earthquakes. Every time they carve, the ground shifts. This is the part most people miss. The city will not be static. It will be alive. The rock will creep. The stress will adjust. The engineers will install sensors to monitor every millimeter of movement. And when the sensors detect something wrong, the evacuation time is not minutes. It is seconds. Because a collapse at 1 kilometer does not give you warning, it gives you a sound, a deep groan. Then, silence. You have never heard that silence, but the miners at the San Jose mine in Chile heard it. When the tunnel collapsed in August of 2010, 33 men were trapped for 69 days at 700 meters. They survived, barely. Their rescue was a miracle of engineering, but the reason they were trapped was not a single event. It was a cascade. One bolt failed. Then the load redistributed. Then the next bolt failed. In minutes, the entire shaft was gone. That cascade is the real danger at 1 kilometer, not one big failure, a chain of small ones. If this made sense instantly, it is because you already knew. You already felt that deep down, the Earth does not want us there. Now we get to the engineering fix, the thing that could make this possible. The Saudis are not naive. They have hired the best tunnel engineers in the world, many of whom worked on the Gotthard and the Brenner Base Tunnel. They know about heat, they know about water, they know about rock creep. Their solution is a triple-layer lining system. The first layer is a shotcrete shell that seals the rock immediately after excavation. The second layer is a steel-reinforced concrete ring that carries the load. The third layer is a drainage membrane that channels water into collection points before it reaches the interior. But there is a catch. That drainage membrane is only as good as its seals, and the seals are made of polymer, and polymer degrades under heat and radiation. The rock at 1 kilometer emits low levels of radon, a radioactive gas that seeps through concrete. Nobody knows how long those polymer seals will last in a radon environment at 45 degrees Celsius. The engineers calculate 50 years, but calculations on paper are not the same as reality underground. The tunnel remembers. it always wins. Think about what it means to commit to living underground for decades. The psychological toll is documented in every long-term isolation study. The crews at Antarctic research stations show measurable decline in mood and cognitive function after 6 months of artificial light. At 1 kilometer, there is no natural light at all, not even twilight. The city plans to use full-spectrum LED lighting to simulate daylight. But the simulations are not the same. The circadian rhythm depends on real sunlight. The human body knows the difference. How many times do we ignore a 2-millimeter gap until it becomes a collapse? Comment what you would seal first. The solution to that was a gasket made of compressed graphite, tested at 600 atmospheres, the same material NASA uses for rocket seals. But here is the thing nobody considers. That gasket costs $2 per meter. The tunnel it saves costs $2 billion. And if that single $2 gasket fails, the entire system fails. That is the brutal logic of deep engineering. The margin for error shrinks to 0. The tunnel collapsed because of that. What is your 2 millimeters? Drop it below. Now we arrive at the core truth. The underground city is not being built for the people who will live there. It's being built as a statement, a demonstration that Saudi Arabia can bend the earth to its will. The residents are not the point. The engineering is the point. And that changes the calculus. Because if the city becomes uninhabitable in 50 years, that is a problem for the next generation, not for the one building it. The real mechanism beneath this project is political. The city is a trophy, a monument to ambition, and like all monuments, it will weather. But underground, weathering is not slow. It is sudden. One fault line you did not map. One pocket of pressurized water you missed. One seal that should have been replaced but was not. The earth doesn't negotiate. This is where it gets personal for you. Because every tunnel you have ever driven through, every mine you have ever heard about, every underground space you have ever stood in, that space exists because engineers accepted the risk and damn well made it safe. But they did not live there. They went home. The surface was always waiting. The underground city removes that safety valve. It says you will live in the risk. You will raise your children in the risk. You will grow old in a place where the weight of 1,000 meters of rock is the roof over your head. And the only thing between you and that weight is a $2 gasket. That $2 gasket is not an exaggeration. It is the exact thickness of the seal between your family and a slow collapse. That kind of truth does not belong to surface dwellers. It belongs to people who want to understand the real cost of living underground. Subscribe to stay inside that understanding. Then comment with your own number. What is the smallest thing you trust with your life? That 500-meter drop you just saw? It took 18 months, 62 tons of explosives, and 3 lives. But the tunnel you will ride through next year will forget those numbers. If you want to remember the cost before you enter the darkness, subscribe. Not for the views, for the vertical truth. The thermal modeling is not optimistic. At full capacity, the city's energy demand for cooling alone will exceed the output of a dedicated nuclear plant. That energy has to come from somewhere. Saudi Arabia plans to power it with solar farms on the surface, but those farms cover hundreds of square kilometers. Each panel must be cleaned weekly, or dust reduces efficiency by 30%. The sandstorms that the underground city was designed to escape are the same sandstorms that will starve it of power. The logistics of that are staggering. Every watt that reaches the underground city has already passed through transformers, converters, and voltage regulators that degrade in the heat. The cooling systems that protect the electronics require clean water, which is scarce in the Arabian desert. The desalination plants that produce that water run on electricity from the solar farms. It is a closed loop with no margin. One sandstorm that lasts 3 days, and the entire system spirals into deficit. The miners at Mponeng know this rhythm. They work in 3-hour shifts because the body cannot tolerate the heat beyond that. They carry ice packs strapped to their chests. They drink 2 liters of water per hour and still lose weight from sweating. At 1 kilometer, the air is thick with rock dust and diesel fumes from the haul trucks. The ventilation system must exchange the entire volume of air every 6 minutes, or carbon dioxide levels become toxic. That requires fans with blades wider than a city bus. Now imagine 50,000 people breathing that air, cooking in that heat, sleeping in rooms that are never dark enough because the light comes from bulbs, not stars. The architects of the underground city talk about green spaces and indoor parks. They mention hydroponic farms and artificial streams. But every single one of those systems depends on pumps and filters and seals that have never been tested in this environment. Not for a year, not for 10 years, for a century. The San Jose mine was only 700 meters deep. It took the Chilean government 17 days to drill a rescue shaft wide enough for a man. At 1 kilometer, the drilling time doubles. The logistics triple. The cost multiplies by a factor the budget documents never show, because nobody wants to calculate the cost of a rescue that might never come. This is the truth that the press releases omit. The underground city is not a home. It is a machine. You do not live in a machine. You operate it. And when the machine breaks, you evacuate or you die. The engineers know this. They have designed escape shafts every 200 meters along the linear city. Each shaft is a vertical tunnel, bored from the surface down, sealed with blast doors capable of withstanding 100 atmospheres of pressure. In an emergency, those doors open and the evacuation begins. But the evacuation is not a stairwell. It is a high-speed elevator, and if the power fails, the elevator stops. The backup generators run on diesel stored in underground tanks. Those tanks are vented to the surface, but the vents are exposed to sandstorms and lightning, and all the surface chaos the city was built to escape. The weakest point in any deep engineering system is the transition zone, the place where underground meets surface, where cables enter the earth, where ventilation ducts draw air from above, where humans walk from light into dark and back again. That zone is only a few meters thick, but it concentrates every failure mode. Water seeps in along the cables. Heat escapes through the ducts. The rock at the transition is fractured from the stress of excavation, and the temperature difference between inside and surface creates condensation that corrodes steel. The ITA report on tunnel failures from 2022 lists 37 major collapses in the previous decade. 29 of them occurred at transition zones, not deep underground where everyone expects the danger. At the edge, at the seam between worlds, the underground city has hundreds of transition zones. Each one is a potential failure point. Each one requires continuous monitoring and maintenance. Each one is a $2 gasket waiting to fail. But the hardest truth is not technical. It is human. The workers who built the Gotthard Base Tunnel lived in a surface camp for 15 years. They went home every weekend. They saw the sky. They breathed the air. The residents of the underground city will not have that option. The commute from the surface at 1 kilometer takes 45 minutes by elevator. That is not a trip you make daily. You go down. You stay down. You become a creature of the deep. The Antarctic Research Station crews report that the first symptom of isolation is not sadness. It is irritability. Small sounds become intolerable. The hum of ventilation, the drip of condensation, the footsteps of your neighbor in the room above. At 1 kilometer, there is no wind, no rain, no birds. The silence is absolute except for the machines, and the machines never stop. The engineers call it acoustic fatigue. It is the reason deep mine workers go deaf not from volume, but from constant low-frequency drone. The ventilation fans, the pumps, the conveyor belts, they all emit a hum that the brain cannot tune out. After weeks, the hum becomes part of your consciousness. After months, you cannot hear silence anymore, because you have forgotten what silence sounds like. The underground city plans to mitigate this with soundproofing and white noise and music piped through the ventilation system. But mitigation is not elimination. The hum will remain. The machines will run. The rock will groan. So when you hear about the underground city of the future, remember the surface. Remember what it means to stand in the wind and feel the sun on your skin. Remember that the engineers who designed this city did not volunteer to live in it. They designed it from above, where the air is free and the light is real. The vertical truth is simple. The Earth does not want us down there. Never has, never will, and every tunnel, every mine, every cavern we carve is a negotiation with forces that do not care about our ambitions. The underground city is the most ambitious negotiation in human history, but the terms are not negotiable. The rock always wins. The cost of that negotiation is measured in more than dollars. It is measured in the bodies of the miners who have already died, proving the physics. In South Africa's deep-level gold mines, the fatality rate has dropped over the last century, but it has not reached zero. Rock bursts still kill. Heat stroke still kills. Falls of ground still kill. Every death is a data point that the next engineer uses to refine the design. Every death is a seal that held until it did not. The underground city compresses a century of that data into a single project. It asks the engineers to skip the learning curve, to get it right the first time, to build a home for 50,000 people in an environment where the margin for error is zero. The rock does not care about learning curves. It does not care about budgets or schedules or political ambitions. It applies the same pressure to every structure, every seal, every human body. And it does not stop. You have never been trapped. You have never felt the weight of 1,000 meters of rock pressing down on every square inch of your consciousness. But the miners who work at that depth every day will tell you the same thing. The first time you go down, you feel it in your chest. The second time, you learn to ignore it. The third time, you stop noticing. That is the most dangerous moment. Because the rock never stops noticing you. The rock never stops noticing you. That is the truth every deep miner knows, and now you know it too. Subscribe to Deep if you want to keep descending into the physics that no textbook teaches. The real pressures, the real deaths, the real engineering that happens where the margin is zero. And in the comments, write one word, noticed. Because the rock did, and it always will. The engineers call it stress redistribution. When you carve a cavern, the weight of the rock above shifts to the sides. The sides then carry more load than they were designed for. Over time, that excess load finds the weakest point. A crack, a fault, a seam you did not see on the survey. because the survey only showed what was there before you started cutting. Every meter of excavation changes the stress field. Every blast, every bore, every cut creates a new map of weak points. The sensors track them. The computers model them. But the models are only as good as the assumptions they are built on. And in deep rock, the assumptions are always wrong. The geology is never what the report said. The water is never where you expected it. The rock is always harder, hotter, more fractured than the core sample suggested. This is the fundamental law of underground engineering. The ground lies. It lies in the survey. It lies in the borehole. It lies in the core sample. It waits until you have committed billions of dollars and thousands of lives, and then it shows you the truth. The underground city will discover its truth the hard way, because that is the only way the truth reveals itself at 1 kilometer. The final loop closes here. The open question that began the video, can a city live a kilometer underground, has no clean answer. It might work for a decade. It might fail in its first year. It might function perfectly for 50 years and then collapse in a single afternoon from a crack nobody saw in a seal nobody checked. The engineering is good. The engineering is the best in the world. But the Earth is older than engineering, and it has never been impressed by human ambition. That $2 gasket will hold, or it will not. The pumps will run, or they will fail. The rock will stay still, or it will move. And you, reading this on a phone made with rare earth elements mined 2 kilometers underground, will never know the difference. You will ride the tunnel, visit the city, marvel at the photos. You will not hear the groan. You will not feel the heat. You will not carry the weight. But the engineers will. They always do. They will stand at the transition zone, the seam between the surface and the deep, and feel the temperature difference on their skin, the cool air of the upper world meeting the thermal plume rising from below. They will check the gauges, the seals, the sensors. They will run the calculations that say the structure is safe. And they will know, in the part of their brain that experience has taught to listen, that the calculation is only a guess. The guess is educated. The guess is backed by terabytes of data and decades of precedent. But a guess is still a guess when the rock is older than the species that is trying to measure it. Every tunnel in history that has stood for a century was built by engineers who accepted that uncertainty. Every tunnel that collapsed was built by engineers who forgot it. The underground city will test the edge of that uncertainty like nothing before. It will push the human body into an environment that evolution never prepared it for. It will force the mind to adapt to a world without horizon, without weather, without the daily rhythm of light and dark that has anchored consciousness since the first hominid looked up at the stars. And it will ask every resident to make a quiet peace with the reality that the ground above them is not a ceiling. It is a ledger. Every meter of depth adds a line to the account. Every year of operation accrues interest, and the payment, when it comes, is collected in full. The engineers know this. They have always known it. That is why they work in shifts. That is why they go home. That is why, when you ask them if they would live in the city they are building, they laugh, not with humor. With the reflexive release of a tension they have carried too long. The answer is in that laugh. The city will be built. The city will function. The city will stand as a monument to everything human will can achieve when it refuses to accept the limits of the world as given. But it will never be a home, not in the way a home is supposed to feel, because home is where the ground is soft, and the air is light, and the weight above you is nothing more than timber and drywall. The weight of a kilometer of rock is something else entirely. It is a promise, and like every promise made to the earth, it will be kept.